All right, so here's a quick overview of the detector refurbishing. The one on the upper right is the one that I refurbished for you, and the one on the left is a completely untouched version that I've yet to restore. And I think it's best kind of to show you how the configuration was prior to restoration and kind of let you know where the weak points are with these things. So just to kind of point one thing out with these 1950s detectors, I think I've already told you this in text, is there are 60, 65-year-old components in these things. During the 5-year, 6-year period of the uranium boom era, they just churned these things out right and left, and not much quality went into their construction. And that includes the electronics as well. So these are probably the better constructed of the two different versions that are out there, meaning the 111B, which is what we're looking at, or the smaller 111s. And like I pointed out, the 111s, the electronic components inside are actually held together with string, like twine. These actually have metal brackets holding the photomultiplier tube assemblies together, so that part is good. All right, so what I'm going to do is I'm going to open up the battery box of an original version and kind of just show you how these things are kind of thrown together in here. All right, I didn't have much to prop this thing up with, so I had to use my soon-to-be-used bottle of Remy Martin here. All right, so this is what we got inside. It's just a very, just a crappy, haphazard arrangement. And reading a lot of the literature on these things over the years, this has been the #1 issue where they break down out in the field, and that is the battery holding component. So the way it works is you pop out this little grommet that holds the wires into the side, and this whole thing comes out. All right, so I'm going to take this apart a little bit more and set this aside so we can look at it closer. Okay, so here's a detector, or I'm sorry, the battery holder. And so these things were built in the 1950s to use the standard carbon D-cell batteries. And carbon D-cell batteries had very low amperage output compared to the alkaline D-cells of today. So you don't need to have 4 D-cells anymore to run these things. In fact, even back in the 50s, it would run for probably quite a few hours with just 2 of the carbon D-cells. But the alkaline D-cells are probably would be equivalent to like about 6 or 8, at least as far as longevity is concerned, 6 or 8 carbon D-cells from 1950 or 55. So you only need 2 now. So they would normally have 2 D-cells here, another 2 on the backside. Now here's another kind of real crappy, bad design. These little prongs here, you have a set here and a set here. And you see how one side is marked positive and the other side is marked negative. And you have the same thing on the other side. So these are where the 22.5 volt batteries go. Now, I believe you ordered a set, and the refurbished unit over here is still going to use the 22.5 volt batteries. So this is what the batteries look like, and you kind of pull the prongs apart and you kind of pop it right in here. The only way this is going to work though, so when you get your batteries, they don't have an indentation here on the electrodes on either end. So you're going to have to use, like, they push in pretty easy to make an indentation, so you can use either the little point here just to push a little bit and make a dent, or you can use like a ballpoint pen just so it snaps in. And I'll kind of show you how it fits in here in a second. Okay, so it fits in just like that. And you can see where the prong kind of fits in right there. And part of the design problems with this battery holder is that the prongs don't have much springiness to them. In fact, they're made out of copper, so they don't really have any springiness at all. And if you pry it apart in order for the battery to fit in, which is what you're supposed to do, it loses its connectivity. So you have to make sure this thing really keeps a nice, good, solid contact, probably either by pushing them in or just testing it. Just make sure the battery's not flopping around in there. Otherwise, you're going to have intermittency issues. And when you have intermittency issues with the 22.5 volt batteries, your meter will go to full deflection instantly. And I mean, you'll have a nice good reading, and next thing you know, you're at max scale for no apparent reason. That will be the reason right here. The other thing is, black goes to negative and red goes to positive. Just because you see a red wire here, that absolutely does not mean that's the positive side. So don't get any confusion on that. Same with this. So, all right. So let's move on to the refurbished version so you can see the difference in kind of how the configuration is going to be. And actually, before we do that, there's one last thing I needed to point out. So these two wires here, which are not going to be in your system, are where the 67.5 volt battery goes. And that is this big guy right here. They don't make these anymore, or actually they do. Excel makes these things, but you'd be paying $60, $70 just for one battery. And it's not rechargeable, so once it's done, you're out 60 bucks. Anyway, you generally only need one of these things to run one of these detectors, but because they're carbon and you know, they want them to last as long as possible, the 111Bs actually recommended using two of these things. So if you ever bought one of these detectors that haven't been opened up yet, it's common that you'd see two of these old batteries still stuffed inside the box along with the battery holder. Okay, so I'm going to make an actual picture of this and forward it off to you as well. It's important to note this is the exact configuration that this thing goes in. So the batteries go over here to the right. The spares that will not ever use batteries go to the, I'm sorry, I got that backwards. The ones that use the batteries go to the left. The spares here that will never have batteries in them go to the right. The power supply unit for 67.5 goes to the left. And this insulator that I put in here, just so you don't have any contact between the battery and the on-off switch. Just stuff's down there nice and neatly. So, and there you have it. I'm going to go ahead and take this out now so you can kind of see how the layout is when it comes time for you to replace the batteries. Okay, so as you can see, the layout is very similar. The only difference is a few extra wires. I have a on-off switch here that controls the 22.5 volt supply. So when you switch this on, it energizes the 67.5 volt battery. It's late, I'm tired, so you're gonna have to bear with me. But yeah, this is the 67.5 volt power supply, and that switch just turns it on and off. Okay, the other thing is, it uses two 9 volt batteries. I'm gonna take these out before I ship it, so you'll have to get some fresh ones for this. And they just pop in here nice and simply. And it lasts for quite a while. I mean, first of all, this is a Curio. I really doubt it's going to be pushed into any sort of actual prospecting service. But for, you know, here and there, turning it on and off and checking out things that you've got, these should last quite a long time. The battery pack here, like I said, you don't need two D batteries. Now, if you wanted to, you could put two extra D batteries in here. There's no reason. You're just wasting money because the two that are on the other side here are more than enough to keep this thing going for hours and hours. It has the standard 22.5 volt prongs on both sides, and it will fit the standard 22.5. You just got to pop it in there. Positive on the right, negative on the left, and then you're good to go once these batteries are in place. So let's see. All right, the plastic bag here. The circuitry in these, again, as I pointed out, really were quickly put together, and there's a whole bunch of things that they overlooked when they put the initial designs through. So one of the things is that the system doesn't have an internal ground that separates the power supply or the batteries or anything from the chassis. And you'll notice that on the inside of the battery box, what they've done is they've put these plastic or kind of hard cardboard paper insulators in here so the batteries and the terminals don't touch the actual chassis, because if they do, it shorts the ground. And that's one of the big problems with these. If you do have a short to ground, even by accident, it'll probably blow out the filaments in one or two of the subminiature tubes, or cause some other cascading disastrous effect. And so that's why they put these things in here. I want to be redundant. That's why I've got this, and I've got this plastic bag. This is a normal plastic baggie that you can get from the grocery store. There's nothing special about it. I want to keep the 67.5 volt power supply wrapped up in that before we put it back in, and I'll kind of show you. And that's about it. It's just kind of wrapped up, and then we kind of package it all back in. Okay, a couple other things to note of importance. The curly cord here, these things are old. They're 67 or 60, well, 65, 66 years old. So they're not the best, but most of them still have a lot of elasticity into them. I wouldn't disconnect the detector too often from the battery box, or you can put this on your belt and kind of walk around like you're in the Old West or anything, because again, they just don't have the elasticity that they used to, and you could probably damage this thing if you overwork it. But this one in particular is actually in pretty good shape. When you get your hands on this thing, you'll see that it's not bad, but if you overextend it, you could possibly crack the rubber or break the wires in here. The wires, again, were pretty low quality. I've got about 5 or 6 of these cords that I've actually removed from these detectors for various and sundry reasons and opened them up. And even on the inside, where they've never been exposed to any elements, you know, these wires are still old. These are actually not too brittle. They've got a lot of kind of rubberiness about them, but I think you wouldn't have any issue. But again, just be super, super careful when you put all this stuff back in the box, because the last thing you want to do is break one of these things off. And if you do, I can tell you exactly where to put it. It's they're not too difficult to wire up, but you just want to be extra careful not to pinch these things. Because one accidental pinching or closing of this on a wire will break the insulation. Then you could have one of those shorts with again, the cascade of disaster, so we don't want that. Okay, so that goes back in nice and easily. One of the things to keep in mind is this is a snug fit. So when you put this back in, you may have to press the outsides of the box away from one another in order for this thing to go in. Just be kind of careful sliding this in, because it will get hung up on the cardboard insulator and knock this thing off. And you do want to keep this thing intact. So let's go ahead and put the bagged power supply in. One important thing to note when you put in the power supply is I put a little sticker here that says top. You want that obviously facing the top. It won't fit in any other direction. You want this to go like this. Okay, so you can see it down in there, and we'll go ahead and put the white plastic insulator between the switch terminal and the power supply. Okay, you can see that floats in there nice and easily. The wires can just kind of wrap around here when we tuck them in place. And there's not much to put these things in here. And that's about it. Close it up, and you're good to go. Okay, so when you first fire this thing up, you're going to turn the switch on the side of the box. Let the switch stay on for probably about, I'd say probably just 5 or 10 seconds at most, so the capacitor can charge up. Obviously leave it on, and then come over here to your main power switch and put it on to 0. Okay, so this is where I'm gonna have to kind of talk my way through all this, because I don't have any operational 22.5 volt batteries. I bought all these things probably about 2-3 years ago, and I've used them so much they're all dead. So I've actually had to use little boost boards in order to make this whole thing work. So I have not been able to test it with these batteries, but I have no worries that it'll work when you put your batteries in. But it's easy to explain when I go through this whole procedure. So after you switch it to 0, this control knob here, which is called 0 adjust, it's just for adjusting it to 0. So when you turn it on, the meter should deflect and then kind of settle back down towards the 0. Okay, if it doesn't go all the way down to the 0, then you could just take a small screwdriver and just kind of adjust this thing so it kind of goes down to the 0. Or if it's below 0, then you can adjust it to make it go back up to the 0 and align it. It's pretty self-explanatory. You won't have any issue with that. Okay, on the right side of these units, they have the time constant switch. They got fast, medium, and slow. The best one to have it on is medium. And basically what this does is it kind of steadies your meter, because if you have it on fast, the meter fluctuates just kind of wildly, all back and forth. Medium kind of slows it down. And then if you have it on slow, I mean, it's really, really slow. And the way these things work is it averages out your fluctuations through a capacitive charge. They actually have a large capacitor between the contacts of the meter. So once you switch this thing around, it switches in these capacitors and kind of slows the meter response a little bit. They actually even have some resistors in play within this as well, so it's a little bit to it. Anyway, you're going to want it on medium, and then for the purposes of calibrating for background, I like using the ADM 300. You could use something else that reads in millirentgens or even microrentgens and kind of adjust accordingly. If you look on the left side of the detectors, after you do the 0 adjust, you have 5, 2.5, 0.5, 0.25, 0.05, and 0.025 settings. For what we normally do for our hobby stuff, 0.05 and 0.025 are going to be your kind of bread and butter settings. So even for calibration. So what I would normally do for calibration is I will put the range selector to 0.025. And for me here in the house, the ADM reads pretty much a steady 15 microrentgens, which in this case would be 0.015 millirentgens. So all you do is you kind of, if it's not kind of in that zone, if you're reading high of the ADM 300 or low of the ADM 300, you just kind of go up to this calibration setting and you adjust it so it reads accordingly with the ADM 300. You could use a pulsar, but there is no input on these things to calibrate with a pulsar. You would actually have to take this thing apart and put some jump leads into the amplifier circuit in order for this thing to read pulses from a pulsar to do a calibration. And these things don't read in counts per minute or counts per second, so even using a pulsar might be kind of difficult. You probably have to use some sort of calibrated test source in order to do it. Mike Wall and myself have been kind of going back and forth trying to calibrate one of these things as best as possible using a test source. And it's kind of hard. These things just do not respond very well to getting absolute accurate calibration using a test source. You can get close. You can get pretty darn close, especially with the ones that came with it. So the one that you're going to get is a test source that's 0.13, and I'll send you the instructions also on how to calibrate using the test source. This one does pretty good, but it's not spot on 0.13. It's just due to the degradation of the grids and everything within the tubes over the years. But for regular detection, this thing is going to be perfectly fine for what we do. And it is actually very close when it comes to the first two scales that we're talking about for background radiation and for detecting, just generally small things that we do with our hobby uses. Okay, one thing too also about the calibration adjust. The first probably about 50% of the range in the calibration adjust, these things usually have a dead response, and the last portion of the range has a very steep rise. So just the very slightest turn with the screwdriver on this thing will give you quite a bit of adjustment. So you just have to kind of be careful with this. You're not going to break anything. It's just that you'll see that it's very sensitive, as they all are. All right. I hope this didn't confuse you too much, but once you start working with this thing and seeing how it works, you'll see that it's actually pretty simple. And if you got any questions, obviously you know where I am, so just give me a holler.